this goes without saying that we are going to learn probability in this course. We will see what probability means for a computer scientist. And before that, let's look at what this particular lecture, today's lecture, is going to talk about. I've already told you that this course is about probability. I will probably explain slightly more, give you a brief introduction of what we want to achieve through this course, what is the idea behind this course. Then we will go to a few administrative details about course timings, Hello platform, course web page, grades, and things like that. And then the major chunk of today's lecture will go on about a slightly bigger introduction to probability, in the sense that exactly what this course is about, why is this course different from what you have learned in your high school. I would like to cover that using few examples. And then, I think you should have a good idea of why you are taking this course and what we are going to cover in this course. Finally, in many of my courses, my first lecture has a small brief marketing pitch, reason why you should, or to motivate you to take this course. But I guess this is a compulsory course for you. You have no option. So I don't need to market it. You're all stuck here. So anyway, since you're all stuck here, let's make use of this time and see what this course is about. So I will give you a minute to read this slide. And I would, so yes, please go ahead. Is there a question? Okay. The slide says probability is useful in almost all aspects of computer science. I would say that that's not true. I would say it's not just computer science, but life. Whatever, almost any science or engineering branch you will go to, you would require probability. It's a very basic subject, which probably came about like 500, 600 years ago in the context of betting. Probably that's where people became creative. They wanted to earn money. So they talked about probability, how to formalize their winning chances and things like that. And it turned out to be very, very useful for science and engineering. You will see in the list, statistics, physics. It's very important for quantum computing, machine learning, all the hot topics in computer science. And I would say this is just not exhaustive. You would see so many areas where probability is essential to explain the concepts. Given the role of probability in all these aspects, we need to learn probability, right? We have to understand what is probability, and that is the main goal of this course. And before I start, I would like to ask you, what do you understand by probability? Would anyone like to take a chance and try to explain to the class what they understand by the word probability?
So can you repeat the question?
Yes, I'm just saying that I just want to understand what you understand from the word probability. So anyone would like to give it a try? One sentence, two sentence?
So probability is like, what is the chance of any event of like, if we repeat that event for many times, then what is the chance of happening of a particular event? That is probability.
Great. Thanks, Akshan. Anyone else would like to take a try? You might be correct with probability half, right? So why not take your chance?
Sir, it's basically how likely an event is to occur.
Okay, great. Thank Disha. So I think all of us intuitively understand what probability is. And if I can capture from the definitions given, the two things which people mentioned, the two words which are used are chance and likelihood, right? This is what we want to understand. We want to kind of, there is an event. Again, the important thing is that nature, life is random. We cannot predict accurately what is going to happen. That means there is inherent randomness in many of the processes, things in the world, and we want to say, oh, this event, will happen with great chance. And this is very, very useful for us, right? Let's take the favorite topic, how to make money. And nobody knows whether a particular share will go up and down. A very simplistic approach would be either the share will go up with 100% probability or it will go down with 100% probability. And you will only bet money on the shares which will go up with 100% probability. Obviously, that's a very simplistic approach, and you are not going to find any such cases because every share any share will not fall in this class. What you want to figure out is what are the shares which are supposed to go up with very high probability, what are the shares which are supposed to go down with small probability, and you want to bet accordingly. So in life you will have many instances. Okay, there is always a chance that there is a tornado coming to Kanpur tomorrow. Does it mean that you should just leave Kanpur and go away? There is a very small chance that the fourth wave of corona can strike tomorrow. Does it mean that we should all stay at home and do nothing? So every decision you make requires some kind of a probabilistic calculation. Inherently, that's why as our brains understand these chances, likelihoods, as a mathematician, we want to formalize these concepts. As human beings, we have always dealt with probability. You take decisions all the time. But like as a mathematician and a computer science, we were computer scientists, we want to formalize these concepts. That's our goal. Any questions about this broad overview of probability? Okay. Let me move on to one part which I would say pretty boring, but let's get away with it. This is about how you would go down with this course. First important thing is course web page. Okay, and for this you need to know that my name is Rajat Mittal and I work in Department of Computer Science, IIT Kanpur. So just by a show of hands, how many people can figure out my web page? Please raise your hand if you can figure out my web page. Again, please raise your hand. So this was this question was probably not to ask how many people can figure out my web page. This question was asked so that I know how many people are still asleep, right? So there are 72 participants and 36 or 40 have raised their hands. I assume rest of them are still sleeping. Okay, yeah. So my point is, all of you know how to find my web page, right? Correct? So if you can find my web page, then you can find the course web page. And this is going to be an important place to know about course announcements and other details. Please keep following this web page, keep looking at it from time to time. That's one place. The second thing is Hello Platform. All of you have used Hello Platform for other courses. We will be using Hello Platform for this course also. We will be putting lecture videos on Hello Platform. Please, you can put down your hands. That thanks for your input. Hello Platform, you're registered for this course. That means CS203 is present in your list of courses on Hello. I will put lecture videos there. I will put other supplementary information there. But most importantly, this is the place for discussion. You should keep looking at it for questions. You should post questions. I highly encourage you to find relevant material about probability, and if you think it might be important for the class, post it on Hello. It should not be just one-way communication. Course web page is a place for one-way communication. Hello Platform, it should be two-way. That means whatever is not clear in the course, please ask questions. If you find something interesting, please share that with all of us. And that way, I think this course will become much more meaningful for all of us. That's the use of Hello Platform. If there is an issue with finding the course web page, or if you don't find CS203 in your Hello login, please send me an email. We will do something about it. Otherwise, I will assume that all of you have complete access to both of these things, and even if I post something on one of them, you know what is happening. Okay. Another important thing, TAs. We have a lot of TAs for this course. They will help you in answering questions on Hello Platform, assignments and grades and everything. I will write their contact details, the ones who will be in touch with you on course web page, and then later as you require to interact with them. Okay, and that will be shared slowly. Final thing, grading. I have written it in red and generally red means important. So let me just say that that's not true. This is not a very important part for us. The most important thing for us is to learn probability. This is a side thing. This will be a side effect of this course. How we will do this is we are going to have 2 assignments, again shared on Hello. These will be subjective questions in detail. You should take your time, answer these. I encourage you to discuss these questions with your friends, but remember, the answers should be written by you. You should not take answers. You should not have a copy of your friend while you write your own answers. That should not happen. And if we find it out, there will be very strict punishment. Please make this thing clear. You can talk to your friends, discuss what could be the approach, what way you can deal with the question. That is fine. But once you have figured out how to solve that question, you will definitely write it on your own. These are assignments. Except that, to just make sure that you are following the course material every week, almost every week, we will have quizzes. These will mostly be in class. I will announce them beforehand. Don't worry, they will not be surprise. And there will be small objective kind of quizzes just to make sure that you are familiar with what is going on in the class. And you see that the weightage of each of them is pretty small, but on the other hand, combined, they are going to make a big effect on your grade. Finally, there will be a final exam, and there is almost a 99%, there is a 99% chance that this is going to be an offline exam here. And this will be the traditional, hopefully no other wave is coming. And in that case, all of you will sit like before in a classroom, and you will give the exam, and it will cover all the content in the course. Any questions about these details?
Good morning, sir.
Good
Sir,
morning.
what about offline classes?
Yes, yeah, Anuj, that's a good point. I would also like to have offline classes. I would be very, very happy. I don't think all of you, there are around 150 people in this course, and Shubhaji took a survey before, and around only 80% people were here. I encourage you to come back to the campus, and I would want to take offline classes as soon as possible. Hopefully, probably after Holy break or something. But let's see. Hybrid mode, I will ask if it is possible to record the lectures in RM101. The only problem is that makes it kind of difficult to obtain the recording, modify it, and things like that. My suggestion is most of you should come back to the campus, and once that is there, we will start classes in the offline. I think that's a much better mode of communication as compared to this. Like now, I can't see any of you. It's very hard for me to see what your reaction is. That helps me teach. Again, if possible, if one or two of you start your videos, that would be helpful for
Sir, request, can you provide this information officially?
you. Which
Manual.
information you mean?
That if maximum all of us are in campus, we would have
Yes,
offline classes.
Yes, I will create a survey, and I will clearly mention in the email that we would like to go with offline classes.
Thank you, sir.
Okay. And there is an entire slide devoted to it. Please remember, the main objective of this course is to learn probability. If you cheat, you are destroying this objective not just for yourself, but for others, for me, and this is going to entail harsh punishments. Obviously, I can't catch all of you. There might be 20 people who might cheat. Though, even if I catch one person out of 20, I will make sure that that person, he or she, will get 20 times the punishment. My suggestion is just follow the lecture notes, look at the classes. This course is not going to be difficult. It's an online mode. I allow you to discuss assignments. I would help you answer your questions on Hello. So if you just take some time and follow the course material, it should be good enough to get good grades. If you cheat, the punishments would be very, very harsh. And after that, please don't expect any leniency from me. At this point, whenever you have questions, whenever you have, if you feel that you lag behind in the course, I would be very, very happy to help you out. But once you are caught cheating, no leniency will be shown. That is the policy for this course, especially because once you cheat, it affects everyone, not just you. Let's start with this, with kind of a slightly bigger introduction to this course. What are we going to study? Why are we going to study probability. Before that, you have looked at CS201. Would someone like to tell me what did you see in this course CS201? What was taught? It was not that long back, right? It was only previous semester.
Street math.
Very nice. Yes, right. And that's why there is a circle for discrete structures on the right hand side. You learned how to count. You learned about polynomials. You learned about abstract algebra. I would suggest that you just unmute yourself and answer instead of putting it in the chat. With screen sharing, it's very hard for me to look at the chat. But yeah, all of you have this idea of discrete structures. And what is discrete structures? Why are they called discrete? You say one of you replied discrete math. What is discrete? Probably asking it as an
Not-
English definition. Yes.
Not continuous.
Okay, good. Yeah. So intuitively, we all of us understand what is a continuous object, flowing, no breaks. A discrete object is something which you can count, 1, 2, 3, things like that, right? So intuitively, all of us understand what discrete is. Probability has, in some sense, two parts: discrete probability, continuous probability. If you look at computer science, probably 20 years back, most of the probability which was used was discrete probability. And any guess, anyone would like to guess why that is the case? Why would discrete probability be more important for computer science?
Maybe because we work with 0 and 1 only.
Great, that's the correct answer, right? Thanks, Harsh, right? Because we are working with 0 and 1, right? Yes, electric signals are continuous, but finally, how we encode information on computer is by 0 and 1. And since these things automatically they become discrete, those are more helpful. Though I would say that in recent past, continuous probability has also become very, very important, especially in the area of machine learning. And that's why if you look at CS203, most of our focus is on discrete probability, the intersection between probability and discrete structures. But there is a small area about distributions, continuous distributions, statistics and all, which we will cover in this course, and it will be part of CS2. So to understand from this, most of our focus would be on discrete probability, but we will also cover continuous probability in some detail. And I wouldn't say in detail, but we will go over this continuous probability too. That's the picture for this course. But as soon as I talk about probability, you might say, oh, we have all cleared JEE. We learned probability for JEE in high school. We are all experts in probability. Why do you need to take a new course on probability, right? Why is it not sufficient? How many people raise your hand? How many people feel like that? Okay. Okay, feel free. This is not a right or wrong answer. Yes. So good. So many people feel that they have already learned probability in high school. Why do we need another course? And many of you actually feel that no, that's not enough. So let me ask people who don't feel that probability in high school is not enough. Why do you feel probability in high school is not enough? Why do we need another course? People who have not raised their hands.
Sir, like I remember when
Mhm.
we used to study high school probability, it used to be sometimes that, okay, the probability for this event is this, the probability of that event is that, and then find the probability of union, intersection, and everything, and all these basic things were covered. So but it was not enough to analyze exactly a realistic scenario. I mean, most of the probabilities were
Sorry, I lost you in the last sentence. Most of the probabilities were.
given to find probability of some event, which I think that is.
I think the connection went down. Please, you can lower your hands now once you raise your hands. Yeah. So this is a good point. I think the point which is made is that you learn basic probability in high school, and as I would like to say, the definition of probability is number of favorable
Need a better
outcomes.
course on this. Hello.
Yeah, I think the connection dropped off. Sorry, we couldn't hear the last sentence, last 2 or 3 sentences. Okay. Anyway, so yeah, the basic probability is number of favorable outcomes divided by total outcomes. That's how, at least at our times, the high school probability used to be, and that's too simple. As mentioned in the previous answer, this is not enough. This does not model real life situation, right? So I don't know who answered that question. Are they still there? Okay. Okay, yeah. So this probability is very, very simple, and it doesn't really capture what we need for computer science, the kind of things which come up in real life. Let me show you by a few examples. Okay, and the first example is not going to do that because this comes from your basic high school probability, right? So this, I think all of you can answer yes, right? Okay, except probably the definition of coprime, right? Is there anyone here who doesn't understand the definition of coprime? Okay, good. Once you know the definition of coprime, this question is pretty simple, right? Is there anyone who cannot figure this out after, like 5 minutes of calculation? So how many total outcomes are there?
36.
Great. And how many favorable outcomes are there? Has anyone computed that already?
12.
Sorry, 12?
Yeah.
Okay. So I trust you on that. And I think most of you can figure out the number of favorable outcomes and you can calculate this probability, right? And these are the kind of questions which you have studied when you were in high school. Now let's increase the stakes, right? Let's ask slightly harder questions. For all these questions, please don't shout out your answers. Just calculate the answers. Let others also give time to read the question and figure out the answers. And then I will ask if someone has figured out the answer, they can tell me the answer. Okay.
Yes, sir.
Yeah, just please wait. By the way, one of the thing in almost all our interactions in this course, in all the lectures, it will be handy if you keep a pen and paper with you. This is a mathematics course. It cannot be taught in a way where I just lecture and you just listen. It has to be something where you keep working out things. So if you have it now, that's great. Otherwise, please, from future lectures, keep pen and paper handy, and then we will have discussions. You will need to work out things and then answer things, and it will be really helpful. Okay, so raise your hands if you have figured out an answer for this. Okay, let me start with Arpit. Arpit, can you tell me what answer did you get?
1/4.
Okay. Is there anyone who has gotten a different answer than 1/4?
Yes,
Keep,
sir.
keep raising your hand. What did you get, Akshay?
1/3.
Okay, good. So one person has got 1/4, one person has got 1/3. Is there anyone else who has gotten a different answer than 1/4 and 1/3?
Yes, sir. Sir, 1/3 plus √3/pi.
Okay. Is there anyone else who has gotten a different answer from all these?
So
1/2.
1/2. Okay, good. Yes. So this was the thing which I wanted to illustrate, that actually many of you are correct. At this point, this question is not really well defined. Okay, please feel free to lower your hands now. Thank you. But this question, you will see that in some sense, half is also a correct answer, 1/3 is also a correct answer, other answers are also correct. It depends on how you define probability. This kind of emphasizes that this number of favorable outcomes by number of total outcomes is kind of a loose definition. And this is going to be our topic for the first week, how to mathematically rigorously define what probability is. That will help us ascertain these ambiguities. This is an example which motivates that we need, more concrete definition of probability. The ones which we have learned is really not sufficient, right? So that we will see how to mathematically define space, events, probability space, probability distribution, and things like that. Okay, let's move on. Sorry, just before that, again, Anushka had asked a question. It is very hard for me to monitor chat. So if you have questions, just unmute yourself and ask. Dear sir, if the number of chords are infinite, how can we arrive at such a probability? Exactly. That is where I'm saying that whatever we have learned as probability in high school, that's not sufficient. That's that's very basic. And even in this infinite case, we want to define what probability is. And that will only be done once we have a framework of probability which makes sense mathematically. Okay. Thanks, Anushka. Yeah, if the internet connection is not good, then just put it on chat. I will try to answer the questions again. Yes. So please read this question. In a minute, I will ask what are your responses. Now, this doesn't.
Sir, you are muted actually.
Yeah, sorry, this question is not about probability, so the answer need not be about probability. This might be about common sense, health, and things like that. So be ready with your answers. Okay, so if you have a suggestion, if you have a reason for this, could you write in the chat? I don't see, no one has an answer. Okay, very good. So yeah, so this is what in general I expect generally when I ask in the class, one person who has already seen this before or you know gives me the correct answer, but most of us would like to believe that the small villages have healthy air and physical exercise and everything, and but we can look, previously there was question 3 and now look at question 4. Sorry, this should be. Uh, the point I am trying to make here is that when you look at the first part or this result of the survey, you would like to blame it on physical infrastructure, health facilities, lack of exercise, more of exercise, cleaner air, and things like that, right? But actually, as one of you answered correctly, this has to do with probability. And you might have seen uh, some of you, as I see, you give the correct answer. You might have seen these statements written, but in this course, we are going to prove it. We are going to mathematically define the framework, and then we are going to see that a small sample can have bigger variation from the average. And small bigger as you take higher and higher samples, you would believe that you are getting closer to the average. This fact is known. Do people know mathematically what is this called? That's fine. My point is, we will see this in action. We will prove these things. Not just that, after that, you wouldn't just remember this from one offhand video or something. This you will understand. That's the purpose of this course. There is something on the chat. No. Monte Carlo is a process. It's not a theorem, but anyway. Yeah. Let's look at this. Okay, yes, law of large numbers. That is the thing. But yeah, there is what law of large numbers is just one. For computer science, we need, in some sense, 10 different variations of law of large number, and we're going to look at them in this course. Any comments? Anything? Okay, so yeah. Sorry. Think of an infinite plane which has parallel lines at a distance of 1 centimeter. Okay, so there is a big infinite plane. There are lines drawn vertically. This is my vertical. I'm artistically challenged. This is the best I can draw. So let's just understand it through my words. There is an infinite plane and there are parallel lines at 1 centimeter distance vertically, right? So this is how you are given the plane. Now you have a 1 centimeter needle and you drop it randomly. It can be turned, rotated, it can be straight, it can be at any position. How many intersections do you expect to get with these parallel lines? Yeah. Again, Sashwat, there are 4 lines here. As I said, because it's hard for me to draw on and create an infinite plane and draw on it, but assume that you have an infinite plane where the plane is filled with parallel lines. So yeah, so the first question here is, what do I mean by how many lines do you expect to get? As I see many of answered 0 or 1 or 2, 0 or 1. So, can there be a single number as an answer? And we will see, yes, there is a mathematical meaning to it. And we will also see how to compute that answer. Okay, as far as I remember, only one of you has answered correctly. But anyway, that's immaterial. But for most of you, you understand that this is something, or even if you can answer this now, you understand that high school probability is not sufficient to answer this question. Right? That is the purpose. And yeah, we will see how to answer this, right? Let's look at another question. Again, if you can figure out the answer, keep it to yourself. Let other people also think about it. Then all of us will share our answers together. Okay, let me just clarify. When I say cancer test is accurate with 95% probability, that means it's accurate on both sides. If you if 100 people have cancer, it will answer yes for 95 of them. If 100 people do not have cancer, then 95 people will get that the cancer answer is, the answer is no. Sorry, there was a question.
So this is data complete.
Again, I asked you to withhold your answers, right? Okay, so if you have figured out the answer, do you mind sharing them on the chat box? Your intuitive feeling is sufficient. I am not asking you to prove it. Okay, so one of you mentioned that, yeah, the data is incomplete. That is correct. This information is not sufficient to find the answer here, but I don't know whether you will be surprised. So some of you might have done a project in your first year or looked at some videos and figured this thing out. But when this question was asked to doctors who have all taken high school mathematics probability courses, I should say 95% of them answered it incorrectly. They would think that, if the answer came out to be positive, then the probability that I have cancer is very, very high. That is not the case. Actually, in general population, where people who have cancer is a very small fraction of people who do not have cancer, the probability that I will have cancer is actually going to be very, very low. It could be, 10% or 5% or something. And again, this is something we will formally learn how to calculate in this course. We will see that this information is not sufficient. What kind of information do we need to calculate this probability? And then finally, what will be the answer? Okay. And this was just small number of questions which I have put in front of you to say why we are looking at this course. Sorry, is there a comment? Okay, and you will see that many of these questions, like if you look at the second question, this doesn't even have to do anything with the probability. There's a simple, it seems like a counting argument or something like that, but we will see that the techniques we develop from probability are actually helpful in answering questions which have no relation to probability. There's a very, very different branch of mathematics called probabilistic methods. This. Hopefully, we will have time to cover that. And even if we don't cover it, we can cover it as extra readings. You can ask, you can share literature on Hello platform. I can share things. Again, the objective is to learn rigorous probability, its use in computer science. Okay, and always tell people it's not a one-way thing. It's not like I am going to give all the information to you. My only benefit is that I have been learning this material for longer time than you. You have looked at this material for 2 years. I have looked at it for 15 years. So I'm in a better position, but I need your help. All of us as a team want to understand more about probability. I will also learn a lot by the end of this course about probability if you stay with me. If you find something useful, if you find a nice question, if you find a nice reference, please share on Help. Okay. The main objective of this course is to learn learn probability. The outline of this course is rigorous mathematical framework for what you have seen till now. That is how we will start. This will probably be this week. And as the weeks progress, we will see different topics. We will talk about random variables. We will define what amount of number of crossings we expect, what amount of money we expect from some random process. All this will be defined using expectation. We will see conditional probability. If this happens, what are the chances that our cancer test is accurate, that I have cancer? These kind of questions. Are two events they do depend on each other? They do not depend on each other. How do we mathematically define it? How do we calculate that? What is the behavior of these kind of independent, or I have written independent red because even if partially independent, slightly independent random variables, what can we say about the behavior of these? And if time permits, we will look at statistics, probabilistic method. There's a brief outline, and I understand that few of these words might not be familiar to you, but by the end of the course, we would hopefully know all of these things. This takes me to my final slide. And as I emphasized to you a lot of time during this talk, during this lecture, learning probability is our main motive. I read a book recently which says that in life we should have a tree where at the top we have the most important goal, then we subdivide it, and the top goals should not change. The bottom goals can change as time progress so that we can achieve the bigger goal. So this is the diagram for this course. The most important objective, which should not change for us, is that we all want to learn probability with each other's help. You keep helping me out, I will help you out. If we have to do that, we have to cover the basic course content. I will do it with 99% accuracy. Some basic things I might skip because I don't know, but I will try to cover most of the things you will need in your future courses. But if you want to understand probability, then you should be honest. You should not cheat in the grades. You should not, because once you cheat in the grades, I don't know what level you are at. And then I will be pitching content at a different level, and it will hurt everyone. I won't understand things, you won't understand things. It's going to hurt all of us. So please be honest. That is the only way you can learn things. Small point, which you will see, I will start lectures at 8 o'clock. If you want to attend the classes, please try to be on time. I will try my best to be here at 8 and start talking at 8 o'clock. The last line, not very important. Optional course content, we will see applications in like probabilistic methods and something. For basic course content, we will definitely see applications, but further applications, if time permits, we will cover. Grades, not an important part. Please, it's very hard for you, the way you have been trained. All of you focus on grades. Please, please de-emphasize that. That's not the important part. The important part is after 4 months, you can say that, you know, you understand enough probability to take on further courses in computer science. That's the objective. Mode of instruction, I would love to take offline classes. We will try our best. I would request all of you, I would ask all of you to come back to the campus as soon as possible so that we can have offline classes. But we will see how the situation evolves. Again, so yeah, remember this diagram. The top things are the more important things which do not change. The bottom things might change depending on the situation. That finishes today's lecture. I would be happy to take questions now.